Welcome. Every once in a while, I want to bring you guys current research, what our industry and essentially what academia is bringing to light regarding the microbiota and the impacts that things like plastics are having on our microbiota. And just recently in a journal called Nutrients, there was an article published that is a great resource regarding the impact that BPA in particular has on our body as well as on our microbiota. And there's a couple of elements that I think are important to touch on. The concept of what BPA is, which is bisphenol A, it's found in a number of plastics, plastics that line the inside of cans, plastics that they use to, seal in canned foods or canned drinks, some of the textiles, certainly in water bottles and other products. So when you think of BPA, it really is it's a chemical found in a lot of plastics. Now, there is a big push to become BPA-free. And yet, the impact of that is that there are workarounds. And what this article points out is there's a number of what we call alternative plasticizers that, in fact, are every bit as dangerous, and yet the studies aren't being done, nor are they being looked for in plastics as a consequence of their replacements. And we'll touch on that briefly. I'm going to show you a graphic on these analogs, as well as some of the research that I want to touch on in terms of the BPA and what it does for, or what it can do to us. And so what it can do to us is BPAs are commonly referred to as endocrine disruptors. You've heard of these xenotoxins in plastics that disrupt endocrine systems. And one of the mechanisms that it impacts us is that it interrupts the genetic genes that control adipose tissue, meaning it turns on genes that increase adiposity, or in other words, it increases your body's ability to store fat. So it contributes to insulin resistance and fat retention or obesity. So that's a mechanism from a scientific perspective of what BPA can do as an endocrine disruptor. Now, there are other things it can do in terms of some hormones, but just let's focus on that bit. And I'm going to show you guys part of this article because I think it's important that we consider the research that's being done. So here's a graphic from this article in Nutrients. And what the article is about is how BPA is being mediated in both good and bad ways by the microbiome, and how next generation probiotics can help us resolve some of these. So at the very end of this, I'm going to tell you some solutions that we can do. So BPA enters the body either through the lungs, the GI, or the skin. Here are the BPA the chemicals that we track. Now, BPA is the one that we've been tracking quite a bit here in the left little diagram. But I want to point out these analogs that are now being used in plastics that have not been and or are not being followed very carefully, and yet they're being used in plastics. Now, this is a concern. You know, I'm not a big sensationalist, nor do I want to scare people, but I do want to give you the information that BPA is becoming more known. So we see things like BPA-free, but what's happening in many cases is it's being replaced by BPS, BPB, TMBPF, and BPF. So there are 4 alternative analogs used in plastics that truly are not being cataloged or followed by people that are trying to correct this problem, get these out of our system. Now, the good news is our body has the ability to secrete these, to both detoxify and secrete them. However, it can become overwhelming because they are everywhere. As you know, the statistics of BPA exposure through all ages has gotten up to 80-90% when you look at the urine or blood in many cohorts. And articles like this will give you that data in particular. But what BPA does is it enters the body. It can pass membranes, so it can pass intestinal membranes, lung membranes. It makes it all the way into the nucleus cell, and it turns on, as an endocrine disruptor, it turns on genes that increase adipose tissue production. That's where it in one of its mechanisms, that's where it causes fat retention and insulin resistance. So this is a mechanism that's well known. However, what's the new information I want to present to you guys is that it impacts the microbiota. So there's two competing stories here. One, exposure to BPA, BPS, BPF, and BPB, and so on. These compounds can create what we call dysbiosis. They're not good for your microbes. However, when we take extra precautions and we work on our gut, meaning that we alter our diet to a much more vegetable and fruit-based diet, when we do that, when we also employ things like probiotics and prebiotics, we can then build back organisms from this event. And these organisms can, in fact, help us detoxify BPA, BPS, BPF. Now, this is new work, so we don't even understand the full complexity, but just by targeting our gut to be healthier, it improves our body's ability to become more resilient in regards to exposure to these compounds. So the take-home message is building a healthy gut will not only prevent these compounds from being more dangerous, but it helps us defend ourselves and helps us detoxify these compounds. That is what the message is. So building your gut is not only critical for how the microbiome affects us, but it turns out the microbiota and in particular certain next generational probiotics are capable of helping us fight this potential threat of plasticizers like BPA, BPS, and BPB in our food, in our water, in various exposures that we experience throughout the day. So again, it's another story that we have to build back our microbiome because it's going to help us fend off or defend against or essentially support the detoxification of these bugs. And that is really remarkable when you consider how many things it can do and what it's doing. Therefore, before I let you go, remember building back the gut using these tools is incredibly powerful. And now there's yet another piece of data regarding how modern xenotoxins can be essentially managed by our microbiota. It's a very, very flexible and dynamic organ. So there you go, and I appreciate your time.